Welcome everyone to another Brian's Backyard Biology. Today we are going to be talking about human threats to the environment. A couple days ago we were learning about some of the different threats that we face in North Carolina in 2020 is in regards to the environment. And today we'll just be talking about some more generalized and ongoing threats that we face. Yesterday, you were looking at climate change and global warming and kind of talking about what global warming actually was as far as the carbon cycle and how that carbon from prehistoric times gets burned through fossil fuels and then enters into the atmosphere, and how that carbon dioxide in the atmosphere can contribute to the warming of the overall global temperature. And so at this particular point, you should be pretty familiar with the difference between climate and weather, right? And the main difference between climate and weather is that you can't weather a tree, but you can climb it. And it's just not the same when I can't hear your groans. So I will imagine you groaning right now over that one. That is not my joke. I am recycling that one, but just love it. So a couple of the different things that we're going to talk about: the ozone. We'll talk about the ozone hole that's there, and then we're going to talk about acid rain or acid precipitation, and then we're going to talk about some specific threats to North Carolina, ongoing specific threats to North Carolina that you should be aware of. All right, so first of all, ozone hole, we've learned about this for a long time. This is probably something that you were first introduced to all the way back in elementary school, learned about it again in middle school, maybe in earth science. It just kept coming up. Remember that ozone is O3. So why is that significant? Well, oxygen is O2. It's two oxygen atoms that are put together. That is the oxygen that we breathe in. All we have to do is add one more oxygen atom onto that O2 that we breathe in, and all of a sudden it's ozone now, which is definitely not something that we want in our lungs. If we get it up high in the atmosphere, in the stratosphere, that is a good thing. It can help to block UV radiation. It protects living things that are on Earth. Almost acts as like a little bit of a sunscreen from the sun to protect the Earth a little bit. But once we get it down in the troposphere where we breathe, that's what we know as smog, and it can be very harmful to us as mammals. It can be very harmful to other plants. In fact, we have ongoing air quality studies in the Great Smoky Mountain National Park that uses plants that are sensitive to ozone, and they have these ozone gardens that they monitor, and they watch those plants to see how well they're growing, so that if they start to see a die off of those plants, then they know that the air quality is probably a little bit lower and something that needs to be looked at a little bit, in a little bit more detail or a little bit more depth. So kind of an early warning system, if you will. All right, so CFCs, these chlorofluorocarbons, are chemicals, and this is where the problem comes in. These were chemicals that were produced because they work really, really well in refrigerants, like in your air conditioner and refrigerators and things like that. Anytime we want to condition the air, CFCs were used, and they were also used in aerosol cans. The problem was that these CFCs, when they interacted with ozone, they destroyed the ozone, they broke it down, and it takes a while for that ozone to rebuild. And so we actually discovered that it was starting to thin. The ozone layer was starting to thin all the way back in the 70s. And if you look back at environmental policy, I know that you're all just rushing to the internet right now to research environmental policy. What you'll find is that most of the environmental policies from a U.S. standpoint, because remember, we can't police the world, right? We can make policies in the United States, but it really stays in the United. That's all that we can really do is set our governance, not control what's happening in other countries. And really, the 1970s was a really, really kind of hot time for environmental law and environmental policies to be put into place. And so we see a lot of these different policies that are put in place. Our awareness kind of came into being during the 1970s. So the ozone hole, as it's called, it's actually a thinning of that ozone layer. Once we started to ban CFCs in the United States and other industrialized countries, and that's the key, we had to get other countries on board, then we started to see that the ozone was regenerating. Now we believe that in 2065, the ozone will be back to normal. And so normal before, what we mean by normal is we mean the levels or the thickness that it was uh, before we started using all the CFCs. And so this is a really, really good news story. I think that it's one of these things where we can show that, hey, if we come together for the collective good, we can actually make a positive change. So, why did this problem ever come into being? And I think a lot of times when we harm the environment, we tend to demonize that, right? um, these crazy chemical companies that are out there, and there has to be a bad guy in this whole thing. What you have to realize is that we didn't know what the CFCs were doing. We do this a lot with different products that we use, and there's constant research that's going on to study how things that we use in our everyday life impact things in the environment. For example, plastics and that we rely on so much, there's evidence that they may break down into microplastics, and those microplastics may get into the water and harm organisms. We had water bottles that had BPA in them. BPA was a chemical that helped to stabilize or the plastic. It made it rigid. This is a good thing, right? We don't want flimsy, your Nalgene bottle. If you drop it on the ground, you don't want it to shatter. Well, that's kind of what this did. It was a stabilizer, and we saw that as a really good thing until we noticed that it had harmful effects. And then people were like, well, wait a second, I don't want to use this anymore. So understand that a lot of these things, a lot of these substances that we use, we continue to test those to make sure that they're safe not only for us, but also for the environment. And then usually environmental policies, environmental laws are made to regulate those different substances to make sure that we keep everybody healthy. And so this is just one of those where we said, hey, this is really, really important, and we got a lot of countries on board. So what it looked like back in the 1970s, if we look at this, the red is actually good here. That means that it's very thick, and the greens, and where we get the darker blue means that it's a little thinner. And so this picture of the globe, we're actually looking at the South Pole. This is a picture of Antarctica, and we can see over Antarctica, especially in the 2000s, that hole that we were talking about, that thinning, is actually pretty defined. And by 2013, we can see that it's starting to shrink and get a little bit smaller. But if we watch this, it kind of ebbs and flows. So it's not like it just sits there all the time. But we have air currents moving around. And so at very particular times of the year, this will kind of form, and then it kind of goes away, and then it forms again. And so there's kind of a cycle to it. And what we're noticing as we track it is we're noticing a trend. We're noticing this downward trend of that thinning, and that's a good thing that we're moving in that direction. So the next thing that I wanted to talk about is acid precipitation, and acid precipitation is actually something that we had to deal with quite a bit in North Carolina, especially in the Smoky Mountain National Park. And you might think, well, wait a second, it's a national park, right? This is supposed to be pristine wildlife, where all the animals can run around and our plants are healthy and everything like that. But what was happening is, as we generated electricity, and in the United States especially, we generate a majority of our electricity through coal. Coal is very cheap to get in perspective to other types of energy. It's easy to transport, and it generates electricity, and we've been using it for a long time. We burn that coal in order to make our electricity, to heat up water into steam to turn a turbine that makes the electricity. And so we have lots and lots of coal burning plants. Well, in the Tennessee Valley, we had a ton of these. And again, in the 1970s, this is where the 1970s, the Clean Air Act came in, and the Clean Air Act really helped to do exactly what its namesake is. It helped to clean up the air. But before that, all of the sulfur that was in this coal as we were burning that coal, because on the East Coast, our coal has a lot of sulfur in it, that was going up into the atmosphere, the sulfur dioxide. It was mixing with the nitrogen oxides that were already in the atmosphere, and when those came together, they formed sulfuric acid. And so we had this sulfuric acid that was forming. It was very dilute, but it was in the rainwater. It would fall, and then all of a sudden we would get acid rain, right? The pH would drop. And once that pH drops to about 4.5, we start to see massive amphibian die-outs and everything like that. It doesn't even have to drop that far. Even if it's in the fives, we start to see some problems with vegetation. And we started to see that in the highest elevations in the Smoky Mountain National Park, as we started to see a die-off of some of the trees that were there because of the lower acid levels. Now, if you remember, 7 is a neutral pH. When we're talking about rainwater, though, in general, rainwater is going to be a little bit acidic. It's going to be in the 6s. And so that's not uncommon. But once we start to drop into the 5s and then the 4s, then we're really getting into some problems there. So if we look at a picture of North Carolina, this is actually Mount Mitchell, the tallest peak on the East Coast here. And in the Smoky Mountains, we have a little map down here so you can see where it is in relation to us outside of Charlotte. You can see all of these dead trees, and those dead trees are an indication of that acid precipitation and just ongoing acid precipitation that takes place there. And those trees just can't survive in that low acidic soil. All right, so those are two main ones. And those are kind of ongoing threats, right? Kind of like our whole climate change concept with the increase in CO2 levels in our atmosphere. And this is an ongoing problem. It's not something that's super specific to 2020, like the newspaper article that we read. Something else that's happening in North Carolina, and these are all ongoing problems. The first one is beach erosion. And the reason that it's a problem is because of our perspective, right? So we have these beautiful Outer Banks on our shoreline in North Carolina. If we look at the map of North Carolina, this strand of little islands that are out there, and some of you have probably visited the Outer Banks. These islands, though, these barrier islands constantly move. The problem is we try to build static, stationary structures on moving islands. And then as people, we get mad when they move, if you see the problem there. So we build houses, those houses are at the beach, but then the island moves and all of a sudden those houses are threatened to fall over. People don't want to lose their property, and so what do? They start to go ahead and add in these breakwaters. They go ahead and start to add in little jetties that go out, and it leads to increased beach erosion that takes place there. And really these islands are going to continue to do exactly what they always do. Okay, this little video shows a little sand particle, and what you'll see is just the way that the waves move. That sand particle, it's going to come in at an angle and then go straight back out, and then in at an angle and straight back out. And so we kind of get this zigzag pattern, but it shows you how the sand continually moves down that beach, right? And so it's constantly shifting, and that's just something that's going to happen. And so we're constantly learning new ways to protect our stationary objects on a moving island, right? The other one is the urban development in the Piedmont. This is actually called the Piedmont Crescent. And if you look at the map again, starting down here, let me get my pointer, starting down here in the Charlotte area, you can take 85, and this really is Interstate 85 to 40, all the way out to the Raleigh-Durham, Chapel Hill area, all the way through Greensboro. And so we have this, and you can hop on 85 and you can drive it, and you're going to go Charlotte to Kannapolis, and then you'll make it out to Salisbury, and you'll continue out. You'll finally get to Greensboro and then Burlington as you go out, and all of these little towns just kind of blend into each other, and you can see those oranges and reds there. That's really high density. So what that means is that any wildlife that tries to move back and forth east to west has a really difficult time, just because we have such a high density of people that are spread across this vast area, right? So this sprawl, and there's a whole lesson just on sprawl of people, this urban sprawl and spreading out of high density areas. Instead of having small towns that are really compact, we kind of spread those out, and it's a way of development. And so figuring out new ways to develop things, it really helps with that problem. Our waste lagoons here, we know that pig farming is really, really important. in North Carolina as far as an economic standpoint. The problem is all of these pig farms are in the east, and we know that we've already had, as of today, we have our third named storm already of the hurricane season, which is very, very early this year. But we know that there are hurricanes. We've already had a tropical storm that's affected our East Coast this year. And so lots of flooding can happen. And when those pig lagoons overflow, then it can release a lot of things that are harmful to the environment that can contaminate drinking water, harm fish. We end up with fish kills and stuff like that. The lagoons are pits. They're kind of like open ponds where the farmers put all of the pig waste. All right, and that sounds kind of disgusting and gross, and it kind of is. But some of the farms are trying to be a little bit more proactive. I've been to a pig farm just south of Raleigh that actually covers their lagoons up with this big, huge cover, almost like a pool cover. You can actually go out and stand on it. It's thick enough, but they capture all of the gases from that waste that's decomposing, and they actually run it through a generator and burn that to generate electricity. And so they're using pig waste to make energy to try to reduce the amount of carbon that they're putting into the atmosphere. And so that's a pretty cool thing that they're doing to try and help the environment. And then the last thing that we have is this bottom left right behind my picture. You'll notice here that we have a lot of what looks like ivy growing all over. This is actually kudzu. You're probably not unfamiliar with kudzu because it grows everywhere around here. And in the southeast, it is a really big problem. The reason that kudzu is a problem is because it's an invasive species. It's not native to this area. And so if you just look at an area where kudzu is growing, you'll notice that it grows up and over all of the native plants so that only the kudzu is growing there, and it kills off all of those native plants. So we're decreasing the biodiversity in that area. And anytime we decrease the biodiversity like that, it's just going to affect everything up that food chain. So it affects the birds and the mammals and everything else that lives there. So those are just some simple threats, some ongoing threats to North Carolina that you all should be aware of. It appears that it's starting to get a little bit too dark on this evening for me to continue filming, so I'm just going to end right there. I hope everyone is doing very well as we get close to the end of the year. So please remember, as we head into the summer, to make sure that you're staying safe. I know that we're sick of being at home and inside, but that virus is still out there, and it is still contagious. So make sure that you're staying safe, stay 6 feet apart, make sure that you're washing your hands, and we'll see you next time.